Identifying Hate Speech in Low Resource Languages, a study on Hindi, Gujarati, Marathi, and Sinhala. Low resource languages like Hindi, Gujarati, Marathi, and Sinhala are spoken by hundreds of millions worldwide. With over 16 million speakers for Sinhala, 300 million for Hindi, 55 million for Gujarati, and 83 million for Marathi, these languages are crucial for daily communication. Low resource languages, often lacking extensive linguistic resources and label datasets, present a unique challenge for sentiment analysis. The scarcity of available tools and datasets makes it difficult to develop accurate and contextually relevant sentiment analysis models. Despite these challenges, the importance of sentiment analysis in low resource languages cannot be overstated. The datasets used for this project are as below. The Sinhala Offensive Language Dataset (SOLT) is a manually annotated dataset containing 10,000 posts from Twitter. The Marathi Offensive Language Dataset (MOLT) consists of 2,500 annotated Marathi tweets. The Gujarati dataset used in the study consists of 5,498 tweets, while the Hindi dataset consists of 4,594 tweets. All the above mentioned datasets can be found in the link given below. Coming to data preprocessing. Removal of non-alphanumeric characters. This step involves filtering out characters that are not letters or numbers from the text data. Removing non-alphanumeric characters helps in cleaning the text and eliminating noise from the dataset. Removal of stop words. Stop words are common words such as and, the, is, etc. that do not contribute significantly to the meaning of the text. Removing stop words helps in reducing the dimensionality of the dataset and focusing on the analysis on content-bearing words. Tokenization. Text is segmented into words or subwords unit, facilitating feature extraction. This step transforms raw textual data into a format suitable for machine learning and deep learning models. Moving on to the exploration of ML models that were used. Firstly, logistic regression, a linear classification method ideal for both binary and multi-class problems. XGBoost, a scalable ensemble learning approach. XGBoost efficiently uses gradient boosting with decision trees for robust predictive modeling. Decision tree divides the feature space based on significant attributes, offering an interpretable structure for classification and regression tasks. Random forest is a versatile and simple technique. It combines decision trees to enhance predictive accuracy and minimize overfitting. Support Vector Machine (SVM) classifies data by finding the optimal hyperplane, making it effective for linear and non-linear classification tasks with kernel usage. Moving on to Gaussian Naive Bayes, a probabilistic classifier based on Bayes' theorem, suitable for text classification and spam filtering, assuming feature independence. AdaBoost strengthens weak learners into a robust classifier by iteratively adjusting weights on misclassified instances, improving adaptability. Gradient boosting, similar to AdaBoost, gradient boosting sequentially builds decision tree ensembles, optimizing for residuals to create a powerful predictive model. K-nearest neighbors classifies data points based on their majority class among the k-nearest neighbors, a straightforward and effective algorithm for classification tasks. Now if we go and see the results of these models, as can be seen in the screen, we can see the train accuracy, validation accuracy, the test accuracy, and the F1 score for the before mentioned machine learning models. Through the training accuracy reached over 0.996 in models like decision tree, random forest, and their validation or test accuracies couldn't maintain the same margin. It can be seen that this suggests model overfitting. Logistic regression has achieved highest test accuracy among all the ML models with 0.684 and a decent F1 score of 0.574. Looking into the DL models. Following models will be discussed in the further video. Neural network. Artificial neural networks uncover complex patterns within text. They connect nodes to map input features non-linearly, aiding hate speech prediction. LSTM, long short term memory. LSTM networks understand word order in text, crucial for recognizing contextual details in hate speech, enhancing model accuracy. CNN, Convolutional Neural Network. CNNs capture spatial hierarchies and recognize patterns in text. They excel at detecting local features, complementing LSTM for hate speech detection. BERT, Bidirectional Encoder Representations from Transformers. BERT, a transformer based model, enhances understanding of language nuances. It consists of bidirectional context, improving hate speech detection accuracy. Upon experimenting with various DL models that were mentioned before, you can see in front of you the results of those models. And as this was not giving a really satisfactory result, the thought of changing the course of experimentation occurred. And that's when the pre-trained BERT model came into picture. And as can be seen, there is a major increase in accuracy and F1 score compared to the previous models. Building on the pre-trained model, additional 2 extra layers were added to this architecture, a CNN layer and an LSTM layer. And finally, this architecture has given by far highest accuracy of 80%. And upon getting a standard architecture, this was tested on various other low resource languages that were mentioned in the beginning. And the model passed the test with satisfying F1 score and accuracy. In conclusion, the architecture of a composite deep learning model significantly influences its accuracy. It was observed that there were instances where the F1 score for certain models declined to 0. However, through meticulous adjustments of hyperparameters and modifications to the model structure, it was possible to achieve substantially higher accuracy than what was individual model could attain. This highlights the importance of thoughtful model design and parameter tuning in maximizing the overall effectiveness of combined deep learning models for such tasks as sentiment analysis. This wraps up the study about identifying hate speech in low resource languages. This study was conducted under the guidance of Dr. Animesh Chaturvedi, and this is Janvi Induri of Data Science and AI branch of Batch 2021. Thank you.